Hello. Today I wanted to respond to a video that I've seen recently entitled Coding Snake in 4 minutes 30 seconds, plain browser JavaScript. It was a video that's pretty popular. I see it's got almost 2 million views. I really enjoyed it. I thought it was great. I thought it was a great way of showing how that with a little bit of coding, I mean with no tools, just a web browser and a text editor, you can create a game in under 5 minutes. I thought that was great. The whole video is actually about 7 minutes, but a lot of it is him talking. Anyways, being a coder myself, I'm like, I can do that, and I'm not going to try to do it in any sort of faster way. In fact, I'm going to try to do it slower, because my one complaint about the video is that it's very non-obvious what's going on when you're watching it. I thought he could have explained things a little bit better, but it's overall a great video, and I'll link to it below, and I highly recommend you watch it, probably even before watching this one. He gives some great nuggets of coding advice. But anyways, I thought, you know what, I'm going to do this video in my way, and show how, explain things in the way that I would like them to be explained. So anyways, let's get started. You see I have a web browser and a terminal up here, so I'm just going to say text editor, snake.html, because just like the original video, I'm doing it all in a single page. So first off, I do like defining my pages with at least some regular HTML markup. So canvas, and I'm going to create a canvas tag, and it needs to have an ID of whatever, game, works well, but also a width, quotes, 400 pixels, and a height, also 400 pixels. There we are. I should warn you, I did one of these videos already, and I realized after I'd recorded it that I did not increase the size of the text in my terminal, making it really hard to read on a video. So I'm redoing this. This is a second attempt. Sorry, but that's how it goes. So we create a canvas tag, and this is using an HTML5 canvas. And what that does is it allows you to draw things in a web page without the regular document rendering. Like aside from that, within an element, I want to draw it pixel by pixel. So it's perfect for doing JavaScript games, if you're unfamiliar. So moving forward, we need a script that'll actually draw this stuff. And so let's do that. Here we are. We're starting with a script. First thing I'm going to need is I'm going to need to grab a reference to that that canvas. So var canvas equals document.get element by ID. I may have made my text too big here. I'll shrink it down if I think it's bad. I use single quotes. What am I doing? Come on. It's like I've never written JavaScript before, right? Game. So what that does, this line, it goes ahead and it references this canvas tag. So now I have a reference to that canvas tag, but that's not enough, because I don't just need reference to that tag, I need reference to that tag's graphics context. So I'm going to say var ctx for context equals canvas.get context, because a canvas element has a get context function where you pass it what type of context you want, and in this case the 2D context. There are other contexts. This was made in a very generic way that you can grab other contexts. So in this case, we're doing a simple 2D snake game. So this isn't too hard. All right. I'm going to indent that the way I like it indented. I don't really have my browser set up for doing both JavaScript and HTML, or my editor. Anyways, the next step we really want to do once we have a couple of these variables is we are going to set a interval. Okay, so this is a regular JavaScript function, set interval, and what you do is you call a function, a yet to be defined game function in this case, named game, and you give it a time. So how often do I want this called? And I'm going to do it just like you did in the video, which is 1,000 divided by 15. So what is that? That is effectively, for this game, the frame rate. What it says is it's going to call this game function, which, I might as well define right here. Oops. So it's going to call this function right here, and it's going to call it once every this many milliseconds. Okay, so that means 15 times per second, because 1,000 milliseconds is 1 second. So every second call this game function 15 times, which will give us a frame rate of 15 frames per second. All right, not huge, but for this game, that is more than acceptable, as you're going to find out. So what actually happens in this game function? Well, first things first, we want to draw something to our canvas. So before we do that, let's go over to the browser, because one of the other problems I had with this guy, not with this guy, the guy's great, he seems pretty cool, with the video itself, was that he didn't show you anything in progress. He coded the entire thing and then said, oh, here's the game, which, you know, if you're trying to get it under 5 minutes, yeah, that's probably the way to do it. If you're trying to have someone understand it, that's probably not ideal. So I'm going to go ahead and we are going to go to File, Home. You can see my previous attempts here. I actually did it once before my bad recording. And I just knew this was Snake. I did it once before that just to make sure I knew what I was doing, so I didn't go and record a video and have nothing happen. So here we are. Here's our HTML page. You can't see anything because there's really nothing to see. I'm going to bring up my dev tools. We're going to look at elements, and hey, look at that. We have a canvas element, and there it is. You can see it highlighted, but of course nothing's happening in it. We are calling something 15 times per second though. So to prove that, first off, let's go ahead and console.log hit. That's a common thing to do. And now I'm going to refresh this, and we're going to see those logs start to accumulate here. And sure enough, here we are. You'll see the number of times that this same message has been written out to the console. It's, you know, in the 140s already. So 15 times per second, it's calling that hit. Not really useful, but we're just going to see that counter climb as I go and I fix this code. So I don't actually need that, but it's proof that that game function is getting called. So what are we going to do 15 times per second? Well, we're going to draw the screen. We're going to draw what our game looks like 15 times per second. So what we want to do is we want to fill the background with black. So I'm going to say set up a fill style. So this is one of the ways one of the functions off of the canvas context, the canvas 2D context anyways, where you set up a fill style. Okay. There's all sorts of different things you can do, but one of the main things is you can set a color. So I'm going to set a color black, and you just do it right like that. And now 15 times per second, it's going to set this to black, but that doesn't do anything. We actually need to draw what we want. And so we're gonna call the fill rect function. In my last video, I found out it's not named fill rectangle. I got an error right away with that. Just want to let you know, even though you've been coding a while, it's okay to, you know, make mistakes. It's okay to forget, you know, the names of functions and libraries and things like that. Everyone does that. It's fine. Just look up the reference material and move on. Don't get discouraged over that. I think a lot of people do, and that's stupid. That's foolish. Anyways, fill rect. So I'm going to start at coordinate 0, 0, and I need to go to, well, I need to go to where? I could just hard code 400, 400, or really 399, 399, and that would do it. But I don't want my game to be that complex. I don't want to have to worry about pixels to pixels. So I'm actually going to set up some variables that say, you know what, this is going to be a 20 tile by 20 tile game. Every tile is just solid colored. And that's the way we're going to do it. So I only want to refer to things between 0 and 19, both in the X and Y direction, rather than 0 through 399. That's the way he did it in the original video, and I think it's a smart way of doing it. But again, it's one of those things that wasn't explained. So I'm going to go ahead and explain it. So I'm going to first set up a tile size. The size of my tile, I want to be 20. I picked 20 because if it's going to be 20 wide, the grid is going to be 20 wide. That means 20 of them will fit in the width and 20 of them will fit in the height. So 20 is good. And then I'm also going to say var tile count. How many tiles are there of size 20? Well, also 20. He defined these in one thing, in one line. You can do that. I'll do that with some other stuff, I guess. But I didn't like doing that. The other thing I changed from the original video is he originally had this named GS for grid size, which I thought was a bad choice of name. Maybe he has some reason for doing that, some sort of experience. He's, you know, more experienced game dev than I am. but this represents the size of a single tile. I don't know why he's referring to the whole grid. That made no sense. So I've renamed it TS for tile size. Tile size and tile count. Tile size, tile count. Got it? Okay, good. Which means, back to our problem here, we need to draw to one spot. So what are we going to draw? We're going to say we want to draw to all the way through tile 20, the full tile count in the X direction, but we have to multiply it by the tile size because this fillRekt function takes pixels and not our arbitrarily defined grid system. So TC times TS is what's going to get us that. So now we're filling this rectangle, which of what will inevitably be 400 by 400, starting at 0, 0. We're filling it with black. That's what we're doing. Let's go over to our canvas and see if that worked. Look at that. We got a big black screen. So that's our game. That's what our game is going to look like. Cool. So what do we need next? We have a black background. I know what we need. We need a player. He has an X and a Y position. So that's our player X and our player Y. That is what he is. So let's go ahead and let's draw him as well. So I did this a little bit different than he did in the video because, well, we'll get to that. But anyways, I just want to draw our player, and I'm going to draw it real simple. He is going to be blue. And now I need to do another one of those CTX, fill Rekt. And I need to go from PX, but not just any PX. It also has to be times the tile size. Because if that PX is 5, I need to draw it at pixel, what is that, 100? So I need to multiply it by 20, by the tile size. So PX times TS, and then the Y coordinate is going to be PY times TS. And then how far left, or how far to the right do I want to draw it? What's the width? Just tile size. And the height, just tile size. So if I do this, also I don't want to define this at 0. Let's get a better value for that. That is going to be, what did he do in the video? I think 10, right in the center of our screen. So let's go and see if we see a blue square in the middle. Cool. I should say what else? One other thing he did in the video that I'm going to do as well is, yeah, I'll illustrate this real quick here by doing a +1. Oops, where did my cursor go, huh? +1. Just moving it 1 over on the grid system. I'm going to draw 2 of these players. I didn't like that connected. Okay, I didn't like that at all. So what he did in his, he wanted little gaps between everything, and I think that's a good idea. So I'm going to do it like that, and there we are. So now when I draw this, you'll see it doesn't draw as big as the full 20 by 20. I'm actually drawing an 18 by 18 rectangle, always leaving a little bit of a gap on the right and the bottom, and I think that's fine. So let's get rid of this example line that I created. And you'll see now we have our 18 by 18 rectangle in the middle. So there's always going to be little gaps between there. I think that was just a nice stylistic technique that he used. I thought that was smart. I thought it was clever. But again, it didn't go explained. So you actually had to look at the code and say, oh, what's that for? Oh, I get it. You had to work it out for yourself, which is fine, but not in a tutorial video. So anyways, there we are. We have a blue square in the middle. It can't do anything. It's just going to stay there because PX and PY are never going to change. We want to change that. So we want that thing to always be in motion once the player starts moving it anyways. And the way we do that is we define a velocity, both an X and a Y velocity. So we're going to have velocity X and velocity Y, and I'm going to set those equal to 0. I think he may have named these like XV and YV. I'm naming them VX and VY. In fact, in the past, I've named them like DX and DY, but V seems okay. I'll stick with V, so it's a little bit less confusing. Anyways, so how do I apply these? Well, what it means is that the first thing we do once we get into the game loop, 15 times per second, I'm going to adjust the player's position. In fact, I'm going to do it with a plus equals by Vx. And I'm going to do the same with y, py and vy. So every time we go through the loop, it's going to add vx to px, and it's going to add vy to py. However, right now you'll see it's 0 and initialized at 0. So if I were to run this, that means absolutely nothing. It still stays exactly in the same spot, and there's nothing I can do about it. So what I need to add is I need to add a handler of some kind. I'm going to do that in this line. I think here's a good spot to do that. So I'm going to say document.add event listener, and I'm going to add the event listener for a key press event, and I want to call the key push function when I do this. What is the key push function? Well, we haven't defined it yet. So it needs to get past a parameter e. You'll see that it gets past the parameter e. That's just the actual event, and I, like the original poster, am going to use a switch statement because I do think they're pretty awesome. And off the e object, I need to look for the key code. And so I'm going to say case 37 means left. Man, this is really kind of... I need to set up my editor for doing JavaScript editing inside an HTML page. It's trying to modify this like HTML, and I don't like it. I don't like the indentation. I'll fix it later. So anyways, when I press left, what do I need to do? I need to take that Vx, and I need to set it equal to -1. And I need to take the Vy, and I need to set it to 0. And then I call break, because that's what we call to get out of a case statement. So what on earth is that? Why did I just do that? What's -1? What's 0? I'm going to explain this. So the grid system up here, this point up in the upper left-hand corner is 0.00. The point down here is the width and height. So that would be 400, 400 if we're talking pixels, and if we're talking the last tile that's here, that would be 2020, or really 1919, and the pixel value would be 399, 399. Us computer guys, we always label everything 0 through n-1. So yeah, 0 through 19, or 0 through 400. Again, we're inline adjusting the coordinate system from what's called logical pixels, which is the 20 by 20 grid, to device pixels, which is the 400 by 400 grid that the canvas actually is. So what I've done is I say the Vx is -1, which means every time it's going to add -1 to this, which means it subtracts one tile from the x direction and moves it to the left, and moves it to the left, and moves it to the left. So every time through that loop, 15 times through the loop, 15 times per second, it's going to move a tile to the left. That's what it'll do if Vx is set to -1. And I set Vy to 0, so that when I press left, it does not move at all in the y direction. It stays exactly where it is in the y direction. So y, for the record, gets bigger as you go down. X goes bigger as you go to the right. So it's a little bit different than you learn in like algebra when you're plotting functions. Anyways, let's go back. That's only what happens when I hit the left arrow. I have other arrows to hit. So I'm going to say yank 3, 3J, and yeah, 3P. Okay, so I just pasted some of this stuff in there. So the next key I hit, the up arrow, that is 38. And if I go up, I want it to not move at all in the y direction, or the x direction, and I do want it to move in the x direction. I want it to move backwards. I want it to move negative. Negative is up. So I want it to move up. So, and now this one's going to handle the 39. That is the right arrow. And this time I want that guy to move positive, x to move positive, and y to stay where it's at. And now 40 is the down arrow, which means this guy is not supposed to move at all, and this guy is supposed to move up. So there we are. Now we've actually changed Vx and Vy for all this stuff, and the very first thing it does in our game loop, if you can see, is it goes, it adjusts my player's position. So did I save that? I think I saved that. Let's watch. what happens? And I can tell you what's going to happen here. There's still a big problem. Well, the problem is I don't know what my problem is. Something is not hooked up right, and I don't know what it is. Hey, isn't that always fun when you're doing a video, somewhat live-ish? I'm changing my VX, I'm changing my VY, I'm adding VX, I'm adding my VY. Is my key thing not hooked up right? Well, we're gonna check one thing here. I'm gonna say, hey, console.log e.keycode. Did I name things wrong? There's all sorts of fun things I could have screwed up here, by the way. It is in no way getting my key push event. Well, that's fun. I hate debugging this stuff live when I obviously screw up. Yeah, it's not getting my key presses. So that's fun. Let's see. I add EventListener. Did I spell that correctly? It would have given me a problem if I didn't. Oh, I know. There is no such thing as a key press event. There is a key down event. Yep. As I said, don't feel bad about making mistakes, especially ones where you just you forget what something's named. So now, yeah, now everything's moving, and you can see my debug window printing out which key I hit. So it's pretty cool. I can move in every direction. Here's a problem. I'm going to go off the screen to the right. What happens? Huh, it just keeps going right. I'm going to bring that guy back. There he goes. Oh, go off the screen to the left. He's like way off of my screen. Let's see. He's coming back over here. Yeah, same with up. And sure enough, same with down. I want this. I want him to wrap around. I want everything to wrap. So we got to make that happen. I'm just going to let him wander off the screen there. And we're going to fix the wrapping part. Also, taking out this log that I used to debug my issue. Again, every time you write a piece of code and something doesn't work, just don't get frustrated. Just go and figure it out. Think of where the moving parts are, what could possibly be wrong, and look for it. In fact, that's like the main reason to keep your code modular and small and simple, is that it becomes way easier to track down the inevitable errors that you are going to make. You know, so plan for failing, and you will always succeed. Anyways, yeah, business guys hate that advice, but it is 100% true. Anyways, we need to make it wrap around. So after I do these initial calculations for the PX and PY, you notice PX can get all the way up to 4 million, which I am not drawing on the screen at all when I'm only 20 tiles wide. So not really all that useful. So let's add some if statements in here. So I'm going to say if PX is greater than or equal to tile count, the number of tiles, because PX is stored in tiles, not pixels, I'm going to set PX equal to 0. So if you're greater than 19 or greater than or equal to 20, which would be the first tile that is off the screen to the right, I'm going to put you on the first tile on the left. And because PX is, it presumably was moving with VX being positive 1, it'll still be 1, and it'll just keep moving around. So, let's do the same thing for the other direction, which is if PX is less than 0, which is the first tile to the left of the screen, we are going to say PX equals tile count -1. And the reason for the -1 is because 20 is off the screen. In fact, 20 is what will trip this condition. So we want it to be at 19, the last tile on the right. Okay, so if I were to save this out right here, we will see that we can now move left and right. Up and down we haven't solved yet, but we know how. So let's go back, and I'm just going to go, what is this, yank 5, JP, and we're just going to change some of these to, basically, just change all the X's in this code we wrote to Y. And because TC is used for both the X and Y direction, this code should just work. And let's see that it does. So we already checked the left and right. Now let's check up. All right, up works, down works. How about that? Okay. So we now have our little self-contained universe where if you go go around one side, you just end up back on the other. That's kind of cool. Some physicists argue that things might actually be that way. I don't know. That's kind of weird. We're all living in a giant game of asteroids. So this is pretty boring right now because that's not really a snake. That's just a dot. We need to make it a snake. So we are going to add more variables. And I'm going to use the same names he did in there, even though I think they're a little bit confusing. I think he did it. Trail is an array. And then var tail is an integer. Tail being how long the trail is, and this is the trail of squares behind him. Oops, I'm gonna write that out. So first thing, we have to actually add something to that. So the way he did it is he says, okay, every time through this loop, 15 times per second, trail is going to have a value pushed onto it. It's going to be a new object. It's x coordinate. It's going to have two properties, x and y. X is going to be the player's current px position, and y is going to be the current player's y position. So, and this gets executed last line in the function, and the very first line is going to be changing px and py so that the player is always going to be one ahead of this. So what this does is it saves and pushes to an array the last place that the player was. Okay, pretty cool. Now we should draw that, and that's what we need a for loop for. And I'm going to use a for loop. You can use other types of loops, especially in JavaScript. For loops are kind of like looked down on. I don't care. I like them. I think they're pretty nice. They certainly work. So I'm going to say for I var I equals 0. I is less than trail dot length and I plus plus. Classic for loop. Now I'm going to say ctx dot I'm going to do a ctx up here. ctx dot fill style. Every single one of these is going to have the same style. I'm going to use the same color that I used in the original video, and it's going to be lime. And now back down here, and I'm going to say fill rect. Yeah, you know what? I'm going to copy. Save myself some typing, right? All right. And this one's going to be trail sub I dot x. This one's going to be kind of likewise, except it's going to be y and not x. Sorry for the wrapping here. Maybe I will shrink down my code. I want to make it a little bit bigger. Shrink down my code a little. You know what? Here. I don't need that much space over here. That's how we're going to solve this. Yeah, that's fine. I like to have my code be nice and big, and this screen is only 400 by 400 pixels wide. I can shrink down my browser and it's fine. So I've gone ahead and I said I'm going to fill this rectangle here with that. Cool. And every 15 times per second, I'm going to add myself a new tile to the end of this guy's tail of where he was last. A lot of you may already spot the problem this is going to create. So this is cool, except wait a second, this looks like an infinite snake. This never ends because I'm not limiting it in any way. So this is just going to, if I move it around enough, I can eventually fill everything up with green tiles. Also, there's no collision detection, so it doesn't care that it's running over its own body, which is, again, infinite because it's adding, 15 times per second. It doesn't even have enough time to draw all the ones that it's adding. So this is kind of a disaster. But it's okay. That's because we haven't limited it. So you remember this this guy right here, this tail equals 5. So that is the limiting factor. So every time I add this, I'm also going to go through a while loop. And I'm going to say, listen, I only want 5 of these things at a time, or I only want as many as the tail is long. So while trail dot length is greater than tail, we are going to call the shift method, trail dot shift. Which what that does is that that shifts the entire array, if you look at it from a left to right, to the left, and therefore pops off the first value. So it's just going to pop off all the values other than all the values past that are longer than the tail. Okay. So let's go and look what that does now. Hey, it's only 5 long. So I've successfully created a snake in a universe where there's nothing to do. There's nothing here. What on earth is this guy here for? So we need to go and create another variable, a couple variables actually. And why not? I'm just going to do these in one. You know what, let's do this. Let's keep this somewhat organized and just do it after this one. Var AX for apple X and AY for apple Y. I don't need to set, I'm going to set to 15. That's what we did in the video. Cool. So we're going to draw an apple. Okay. And every time you go through your draw routine, remember, like, you know, remember the order of these things, right? Of all your drawing functions. So first thing, we draw this black. If this guy was the last, if this was the last drawing thing we call, we would only ever see a black screen because we'd be drawing on top of everything else. So after this, we draw the lime, and after this, we draw the head. So the head's on top. Underneath that is the lime tail. Where do I want the apple? I want the apple to be on top of the tail. So if they're ever occupying the same spot, I want the apple to be on top, but I want it to be under the head. Like, as if the head's touching it, I want the head to be eating the apple. So I'm going to put that in between these two, and I'm just going to do this by copying, pasting, and this is pretty simple. Change that one to red, change this one to A, change that one to A, and now I have a function for drawing the apple. And there's our apple. Cool. So this is really starting to look like Snake at this point. Anyone who sees this, if I were to screen cap this, would be like, oh, that's a game of Snake. I see it right away. So we're getting there. We're definitely getting there. Unfortunately, if I eat the apple, well, I don't eat the apple, nothing happens. Nothing happens when I do that apple. So we're going to have to add some collision detection for the head, the blue one, you know, the PX and PY, and the apple. So we're going to do that right here. So if PX equals AX and, not or, PY equals AY, we want to do something. What do we want to do? Well, first things first, we want to say, hey, you're supposed to add one to the tail, if anyone remembers how this game works. So let's see what happens when I do this now. So that means every time I go through that red dot, my tail gets a little longer by 1 because I went ahead and added, I added one to tail, which meant that when it popped off the excess members of the trail, it popped off less of them. It said, yeah, I allow you to be, you know, 10 long, whatever, instead of just 5. So every time through there, I get a little bit longer. Now, I still have the problem of I can collide with myself and nothing happens. Jeez, I almost need to be longer to die. Yeah, there we are. I can also go back through my own body like that. That's kind of a fun-looking thing. That should, you know, kind of kill you or reset you as we're going to make the game once we get the game working. But yeah, okay. That's fun, but we still need to do a little bit more because that apple should not stay in the same spot. So when we add one to the tail, let's set a new place for the apple. So a new X is going to be math.floor, which, you know, takes it's a floor operation. It means if you have a decimal, it's going to round it down. Basically means to, like, kind of round things down. Floor of math.random, which will give me a random number between 0 and 1, a random decimal, and that's going to be times what is it? Oh yeah, tile count. So if we do a floor of this, it'll give us a value between 0 and 19, which is exactly what we want for a random value here. And then I'm going to do the same thing for the Y value. So if we go and reset this, it at least moves the apple to a new location. Oops. Each time. But you'll see there's still like one main element missing from the game, and that is, well, here, let me show you. Basically, it means I can't die, so I'm kind of playing in God mode right now. I can go back through myself. I can break all the rules of Snake because I haven't written anything that says, hey, what happens if you touch your own tail? And if you think about the rules of Snake, if you're watching this go around, you know that basically if that blue dot the blue rectangle ever occupies the same space as one of the green rectangles, this guy gets reset to default. You lose all the gains you've made. Admittedly, this is still pretty fun right here. I kind of like playing Snake in God mode, but we're not done. We're not going to be lazy about it. You know, playing with infinite ammo just isn't fair. Everyone knows that. It is fun, though. Man, it is fun. I remember doing that back in the 90s. That was great. Anyways, let's go and figure this out. So we'd have to loop through. We can do our collision detection right here where we do the rest of it. We'd have to loop through every single one of those green squares and check whether or not we're occupying the same space as the blue square. But we already kind of have a loop that loops through all those green squares as we're drawing them. So this is where the coding is a little kind of shady. Like in a real application, you wouldn't just put in collision detection logic right next to drawing code. That's just kind of a bad design. But we're doing it. It's the way they did it in the original video, and you know, it's clever. We're supposed to be doing this in like, you know, less than 100 lines of code. So yeah, whatever. This is fine. In fact, he explains his philosophy on that in that video, and I agree. You should probably listen to it. So anyways, we're going to put an if statement here that says, all right, if px equals trail sub I, if I can type today. I can never type when I'm recording video. X and py equals trail sub I dot y. What do we do? What should we do? I know. Tail equals 5. Real simple. We just reset that value. That tail value has gotten out of control because we ate so many apples, and we need to reset it down. So this is our dying condition. Like, you know, this would be if we actually had a game over in this game, it would be right here. This would be game over. So with this, we're at like, what, 85 lines of code. I think we're done. Let's cross our fingers and see if we actually have a working game here. So let's first check. I can move around. Awesome. Notice I can still move through my body, but since there is no game over, it's just resetting me back down to 5, and I'm still only at 5. That's fine. If I go off the screen to the left, I go right. If I go off the screen to the right, I go left. Up, I go. Or if I go up, I come from the down, and if I go down, I come from the up. If I eat an apple, I extend by 1, and the apple moves. And I actually have to get a little bit longer in order to run into myself. But actually not. I can just go back from myself. So if I'm going left right now, if I hit the right arrow, I would expect me to go back to only being 5 long. Let's see what happens. Hey, it worked. I'm only 5 long. Let's make that a little more exaggerated by playing some more. Also, I like playing this game. You know, this is a rather addictive game, which is why it used to be on like every cell phone back before smartphones were a thing. It was one of those old Nokia phones, something like that. I don't even remember. But yeah, we actually have a working video game here that we wrote in, you know, about a half an hour's time. I think we're only at about a half an hour. And let me go ahead and run into myself. Oh, I died. Yep, that's what happens. Commit little snake seppuku there. So, well, now I'm just playing Snake and not teaching you anything about coding. So I probably should end the video, but yeah, this is how you create Snake. I hope that if you watch the other video and were a little perplexed, that this helped you out, because I didn't really change a whole lot. He didn't color his head any different. In fact, he didn't even draw the head. He just drew the tail alone and said, yeah, that's good enough. I didn't think that was good enough, so I actually drew the player's position. Yeah, technically in his game, you never actually saw where you were drawing. Like, you were only seeing where you have been. You were never seeing where you actually currently were. But with a simple game like this, it really doesn't matter. Like, it could be argued that his is a more correct implementation. Oh, there I died again. Which, you know, is what I'm supposed to be testing out rather than just eating apples. Anyways, I'm wasting your time as of this point. I'm going to go play some Snake. Thanks for watching. Bye.